Alright, so we're going to work through the sample problem that's on page 468. This would be an example of a way that you can use calculations to determine the results of a redox titration. So we're going to use some stoichiometry techniques that you learned in Chem 20. And then it actually ends up being a pretty basic calculation. So if you read the problem in the textbook on page 468, we are told that we are going to use a KMNO4 solution with a concentration of 0.00 0.01143 moles per liter of KMNO4, and just to be clear, that's going to end up being the same concentration then of what the just the MnO4, the permanganate ion is, so we'll get to that later. That's the concentration that we're used, and we're trying to determine what the percentage by mass of the hydrogen peroxide is. So on the bottle it'll say 3%, but we know that hydrogen peroxide breaks down on its own, decomposes into water and oxygen, and so we want to see how much of it is actually left, and so we're going to do a titration. So we have in there we are told that we have a mass of H2O2 of 1.423 grams. Okay, and then we dilute it. That dilution actually doesn't affect it because that is just adding extra water. We're only concerned with the actual mass of the H2O2, so that doesn't change by diluting it. Okay, so the titration happens just like what you saw in the other video, and the final result of how much MnO4 you need to add is 40.22 milliliters of KMNO4. Okay, so that's the initial information that we have, and we are ultimately trying to find the percent by mass of H2O2. Okay, so that information is all out of your textbook. We need to figure out what we are going to do with this. So first step always is to write a balanced equation. And so the equation of what's actually going to happen is we are going to have MnO4, okay, MnO4 minus, and we are adding that to H2O2, and that is turning into oxygen gas, and there is going to be some Mn2 plus ions as well as some water. Okay, now this would be an example of one that you could use the half reaction method to write out what the balanced equation is. On this video I'm not going to show you that. I think on the previous video that I attached the link to, there was an example of that working out. Otherwise you could also look in your textbook, but by this point we should be getting better at that. So the actual balanced equation works out to 5 H2O2. This is just out of your textbook, but you'll be able to figure this out on your own as well. Okay, 5 H2O2 plus 2 MnO4 minus plus 6 H pluses, okay, and that is going to produce 5 O2s plus 2 Mn2 plus and 8 waters. Okay. Notice that this 6H plus, that means that we are in an acidic environment, and if you read closely, we've added a little bit of dilute sulfuric acid. The sulfate ions end up just being spectator ions, but that makes it an acidic environment, and so you can balance using that H plus. Okay, so now that we have this balanced equation, the important parts of this you can see come from this and this. Okay, those coefficients, that's the molar ratio between the MnO4 and the H2O2. That's going to become important when we figure out how many moles of MnO4 we've added, because that many moles will react with 5, or with a ratio of 2 to 5 of the moles of H2O2. And remember, we're going to hopefully solve for the mass of H2O2, but we need to get the moles of H2O2 first. So if we go back to our original information that we had, we were told that the number of liters or milliliters, right? We said that there was 40.22 milliliters of MnO4. Of the MnO4 ion that was titrated, and the concentration was given to us as 0.01143 moles per liter. Okay, so how many moles then were actually involved? Well, this is just stoichiometric calculation here, right? We want to determine number of moles, and so we start with what we know. We know that there was 40.22 milliliters, so we'll turn that into liters right away. 0.04022 liters, and then we're going to multiply by the ratio that leaves us with moles and gets rid of the liters. Okay. So that ratio is the 0.01143 divided by 1 liter, okay, which means that we have 4.597 times 10 to the minus 4 moles of MnO4 minus produced, or used in the titration. Okay. We need to figure out how many moles that corresponds to using that 2 to 5 ratio of how many moles of H2O2. So if we have 4.597 times 10 to the negative 4 moles of MnO4, okay, we want to figure out how many moles that gets us of H2O. So H2O2. Number of moles of H2O2. Okay, so again we do a calculation. We have 4.597 times 10 to the negative 4 moles of MnO4 minus. We want to multiply that by a ratio of moles of MnO4 minus on the bottom, and moles of what we want left, the H2O2 on the top. That way that's going to cancel off. Okay? And so that mole, if we go back to our, or that ratio, if we go back to our original equation, says that for every 5 moles of H2O2 used up, you'll also use 2 moles of MnO4 minus. And so when you do that calculation, the number of moles that we get of the H2O2 will be 1.149 times 10 to the negative 3 moles of H2O2. Okay? So if 1.149 moles of H2O2 are used up, how many grams is that? Okay, so if we look at what our molar mass of H2O2 is, we have 0.002 grams per mole. Okay, you can figure that looking that up at a periodic table with molar masses to calculate what that is. And so we want the mass, right, or the number of grams, I guess. Okay, number of grams of H2O2. Okay, so we start with what we know again, 1.149 moles of that, and we're multiplying that by a ratio. It gets rid of the moles and keeps the grams, and so that is 34.02 grams per 1 mole of H2O2. So that works out to 0.03909 grams of H2O2. Okay, then we want that as a percentage of what we started out with, so we go 0.03909 grams, okay, divided by the amount that we had of the unknown concentration was 1.432 grams. That's from the question. We multiply that by 100% to put it in a percentage, and we end up with 2.730% by mass of hydrogen peroxide. Makes sense because we started out with, on the bottle it said 3%, and so it looks like just a little bit has decomposed. Okay, that is how you would solve a question like this.